Okay, hey guys, welcome to lesson 10 and 11. That's probably going to be lit on Wednesday, which means that tomorrow's Dia de Niños, so have a good day off. I'm not going to say that you guys are niños, but have a good day off, okay? I guess you're niños maybe if you're not adultos, but niños doesn't really feel like you're niños either. So anyway, okay, today's lesson, well the very first one, lesson 10 is about Pythagorean theorem. Guys, say that because if you don't know it and you don't want to know what it's called, you'll be like, the what? The what theorem? Pythagorean theorem. The Pythagorean theorem is how you solve for the sides of a right triangle. It's a right triangle because there's your angle right triangle, okay? You use your formula that you guys have probably learned before, but honestly, Paula and Ashley, you guys maybe have seen this in like Algebra 1/2, but in Algebra 1, you guys did this at home during the bad fourth partial pesadilla. Okay, so I don't know if you're very familiar with it, so here we go again. Okay, the formula for finding the sides of a right triangle are a squared plus b squared equals c squared. Super easy formula to use just as long as you apply the right rules. The right rule is this. This diagonal right here is called a hypotenuse. Everyone say hypotenuse. It is always C. It is always C. You can never call this A, you can never call this B. But these two sides over here, you can you can interchange. This could be the B, this could be A, this could be B, this could be A. Doesn't really matter, okay? But this always has to be C. So how do we use it? Well, you have here that you need to solve for A in example 1. Okay, well, then if this is A, then this is B, and this is C. This is always C because it's the diagonal line, okay? And then you just use the formula. So you have A squared plus B squared is 4 squared, that's going to be 16, equals C squared, which is 49, because it's 7 squared, okay? And then you solve for A. So you subtract 16, you get 33. Then you have A squared. Then you're like, now what do I do? Because I need A by itself. Well, what is the opposite of squaring something? I'm going to tell you, okay? In case you're just looking at me like, I don't know. Okay, the opposite of squaring something is taking the square root. So if you take the square root over here, you have to take the square root over here. So your answer is square root 33. Because 33 is not a perfect square root, so you just have to leave it like that. Square root, make sure I follow over the whole number. Square root 33 is your answer, okay? You could easily check it if you wanted to because anyway, if you want to learn how to check it, just call me and I'll let you know because I'm not going to overcomplicate life. Okay, let's look at example 2. Okay, 10.2 is a cool little trick that they want to teach you. And honestly, this kind of stuff tricks me on like big exams that you take like for the government and stuff like that because I always forget what they're trying to ask me to do. This time they tell you what to do, but a lot of times they're not going to put this part in there. It says 10.2, use the Pythagorean theorem to find the distance between 4, 2 and negative 3, 4. So you have it on a graph. You don't really have to put it in a graph, but it's good for you to put it in a graph right now because you're going to be finding the distance between this point and this point. It says to use the Pythagorean theorem, so it already tells you what to do. A lot of times in the test, it's not going to tell you to use the Pythagorean theorem, and you're like, how was it again that I'm supposed to find the distance between this and this? There's actually another way to do it with a different formula, and it's like super easy. But what if you don't remember the formula? Okay, so if you don't remember a formula on a big test or something like that, well then you're sunk with doing that kind of formula. So here's another way to do it. How do you find the distance? Well, first of all, you have to see that there is an invisible triangle here that we are missing. Okay, so I'm going to show it to you. Okay, there's your invisible triangle. And you're trying to find the distance between this and this, which means you're looking for the C. And over here is the A, and over here is the B. Okay, but now we need to find these sides. What is the A and what is the B? Okay, well, this is up at 4, right? Let's put that as the Y. This is up at 4, and then this one is down at 2. Okay, I don't trust my drawings right away. I trust my numbers. Okay, this is 4 for Y and this is 2 for Y. So what's the difference between 4 and 2? 2. So A is 2. Okay, I'm just gonna let you know that's how I do it. Then to find the distance for B, well, I know this is negative 3, right? And this is 4. So let's count it down here. From negative 3 to 4 is going to be 1, 2, 3, 4, 5, 6, 7. So there you go, there's 7. An easy way to do that, by the way, is to go 4 minus a negative 3, which is going to be 4 plus 3, which is going to be 7, okay? So now we're ready to do our Pythagorean theorem. You might have to watch this example twice, by the way, because I know it's a little complicated. But here we go, let's do our Pythagorean theorem. A squared plus b squared equals c squared. So you have 2 squared plus 7 squared equals c squared, right? So you have 4 plus 49 equals c squared. I'm going to move it down here, so that's going to be 53 equals c squared. So it's going to be square root. So c equals the square root of 53. And then we check and see if that's the right answer, and it is. The distance between those 2 points is
Okay, I'm going to
put the practice at the end for 10 and 11, because maybe you're not going to need like the explanation for 10, so I don't want to kind of take up your time with that, but make sure you watch it in case you need it. Make sure you watch it if you need it. Okay, look, on this one it says addition of fractions and inscribed angles, so there's 2 different concepts in 11, but we can go through it quickly, okay? These are fun, you're adding these. I think they're fun even though I hate fractions. So if I think it's fun and I hate fractions, it's not that hard, okay? First you have to find a common denominator. Anytime that you add fractions, you can find a common denominator. These are actually easier than numbers, you guys, sometimes. Okay, what's your common denominator? Well, 2, because it's the only number that we have here. A, how many A's? Well, there's 1 here, 1 here, 1 here, so there's only going to be 1 here, okay? You find all the letters, and then you find the letter to the highest power, and that's the one that you have to have here, okay? So like X is present, well you have an X2 here and X to the 3rd here, so it has to be X to the 3rd to include all the ones in that denominator, okay? Then, you go individually through each fraction. This is how I do it. You look at this one right here. It has 2A. What is it, falta? What is it missing from the denominator? It's missing the X to the 3rd. So you're gonna have to put that X to the 3rd with the K. K, X to the 3rd, okay? Because it's missing that. If you don't believe me, you're like, well, why do I put it on the top if it's missing it in the bottom, Miss Jessica? Because watch. Let's say you have K2A. You want it to say K2A, X to the 3rd. You say, okay, it's false to the X to the 3rd, so you multiply X to the 3rd here. And if you were to simplify that, you would cross out the X to the 3rd, X to the 3rd, and you would be left with K2A. That's how you know it works, because you're left back with the fraction that you wanted, okay? So you look at what's falta, and you put it up at the top of the numerator. So let's look at this one. What are we missing here? We're missing a 2, so let's put that there. And we're missing an X, because this is X to the 2, and we have X to the 3rd here. So we need to put BC X for what we're missing. Minus, what are we missing on this one? Only the 2, so it's going to be 2M. Okay, and that is your answer. I'm just going to check and see if they go in any simplified form. Nope, this is your answer right here, guys. Okay, for finding what your fault in the denominator, putting it on the top in the numerator, and then putting it all over one denominator. That's all you have to do. Let's look at example 2. Okay, same thing as the last one, just a little weird looking. As soon as I see that I have one without a denominator, I put a denominator there. Just gonna let you know that, okay? So that it all kind of looks consistent and it helps me see it easier. Okay, so let's put our line here and find our common denominator. We have an A, only one, and then we have a K to the what? K to the squared, okay? Because that's the highest one over here. So we look at this one right here, what do we felt that? We're felt with an A and a K. So we have A, M, K. Oops, A, K, M, right? Because I like to keep it in alphabetical order for organization. Okay, so we're felt with an A and a K. We put it up here, A, K, M. Minus, don't forget your minuses. We're felt to everything here, so we put A, B, K squared. Plus nada here, so you're just going to put CS. And there is your answer. Told you they're easy. Told you they're that's why I like them, because they're pretty easy. Okay, now we're going to go into the last section, which only has one example, which is good because I have to draw a circle. And it would take me a long time to do more than one. Okay, I'm going to speak a little slower on this part because it's foundational and it's new and it's super important that you understand so you don't frustrate yourself later on, okay? We are now talking about angles and their relationships within and without a circle, okay? It's called inscribed angles. Inscribed angles are the angles inside a circle, okay? There are degrees inside a circle. How many degrees are inside a circle? 360. And guys, this is new for you, there are degrees outside a circle. And guess what? It's 360. So if you're talking about the degrees, the grados, measuring inside a circle, it's 360. And outside a circle, it's what? 360. Okay? If you see an angle inside a circle, and it's coming from the center of the circle, whatever the angle is here, it's the same as the outside, okay? So let me show it to you in purple. If this is 44, then this angle right here, with that sector, on the outside is also 44 degrees from here to here. However, if you see an angle inside a circle that is coming from the other side, see, this originates from the other side, it doesn't originate from the middle. It originates from the complete opposite side. And you want to know the degrees on the outside of the circle, you have to multiply it by 2, okay? So the outside is double this. So if you get this, you multiply by 2. But if they give you this, you divide by 2 to get this, okay? So let's repeat that again. Inside the circle in the middle, it's equal. Inside the middle on the opposite side, this is half of that, or this is double this, okay? This is the small one, this is the big one, it's double this, okay? So how do we apply that to finding x here? Well, you find all the missing puzzle pieces that you can, okay? So what does that mean? We know from here to here, see right here, is 5x degrees. And from here to here is 7x degrees. And remember, 7x plus 40 degrees, pardon. The whole circle is how much? 360. But we don't know the last missing part right here. If we did, we could just add them all up and equal 360. Well, how could we find that extra part? By this guy, okay? He's not in the middle, he's on the other side, like this one. So if this is 40 here, and this is always the bigger one, this has to be what? 80. It's double what this is. Now that we know that this is 80, then what can we do? We can go 5x plus 80 plus 7x plus 40. So let's do that. So that's 12x plus 120 equals 360, right? Because that's how much a whole circle is. And then we just solve for x. I hope you say, Miss Jessica, that was so easy. Why are you trying to make us scared and say that it's hard? It needs to be easy right now, you guys, so that you can do the hard ones later. So if it's not easy, back it up, watch it again, so that you understand what I'm trying to say, okay? Then stop it and do your practice, and we'll make sure that we understand everything.